Hey, good afternoon or good morning, whatever time you're watching this. We're going to go through the experimental procedure for activity 1 in creating our magnesium chloride solution. So we're going to go over to our stockroom and we're going to look at the solutions that we have available and what we're going to need for today to create a 100 milliliter magnesium chloride solution. So we're going to need some distilled water. Let's toggle that. Go back into our stockroom. We're going to need our solid magnesium chloride. We can choose that. And then we're also going to need some glassware. Let's go back into the stockroom, choose glassware, and go to volumetric flasks. And the one that we're going to use is the 100 milliliter. And then we're also going to move down a little bit, and we're going to choose other, because we also need a weighing dish, a weighing boat. And there's our weighing boat. Now, if we go to the top of this screen, back to tools, we see that we have a scale, and there's our scale. So what we're going to do is we're going to make up a solution that has 1 gram of magnesium chloride. To do this, the first thing we're going to do is take our weighing boat and place it on our scale. And if you notice, the weighing boat weighs, in this case, 5.7481 grams. A nice, easy way to account for that is to use the tare button on the scale. What that does is it sets the scale at 0, accounting for the mass of the weighing boat. Now it's at 0. We're now going to add magnesium chloride. So we're going to move the magnesium chloride over the weighing dish. And you notice now we have a spatula. We have the magnesium chloride's open. Let's precisely add 1.00 gram, 1.000 gram, and pour it into our weighing boat. Okay, so if you recognize, let's get rid of this. We can get rid of this by hitting X, and we can move our magnesium chloride out of the way. And we see that we have 1 gram of magnesium chloride in our weighing dish. Our next step is to add this to our 100 milliliter volumetric flask. So when we are in the lab, we would carefully take our weighing dish and we would move it over top of our volumetric. And once again, we're going to get this pouring piece of data to pour in our magnesium chloride. Let's add the 1.000 gram and pour it in. Pour it. And let's get rid of this. We don't need this for the time being. Let's get rid of our weighing dish. It's all been emptied. We can right tag our mouse and hit remove. And now we can move our volumetric up and get the scale out of the way. And now we've added our magnesium chloride. The 1 gram has a volume in that flask of 0.43178 milliliters. Okay, now we're going to add our distilled water, and we're going to add enough distilled water such that the meniscus, that's the curved portion of the liquid of the solvent in this case, and now it's in a solution, touches the bottom line of the scale marking on our volumetric. Now, when we add solvent to a salt, such in this case water to a salt, there are some interactions that we can't well predict the volume change that will occur. So these are rather unpredictable. So normally what we do is we add maybe half of the volume that we would require for the complete solution that we're creating. Let it swirl, shake it, allow the interaction of the solvent and the solute to occur, and then continue adding enough of our solvent till the mark of this reaches the scale marking, which we call the meniscus. So let's bring our distilled water over top of our volumetric flask. And now we're going to get another of these pouring data that we're going to add. In this case, we're going to add 50 milliliters. Good place to start, about half, and let's pour it in. So when we pour in our 50 milliliters, There's been a volume change, temperature change also that's related to the thermodynamics of solvation. You'll learn about that in Chem 1120. And now our new volume is 50.236. So you see it's rather unpredictable to really say how much water we would directly add to that beaker or that volumetric flask initially. So now we would let it swirl and we would let it stand and let the magnesium chloride dissolve. We can now predict about how much water we would need by taking the difference between the 100 and the 50.236. So what we would have to add is an additional 49.764, which is the 100 milliliters minus the 50.236. And we're going to pour that in. So once we pour that in, we see that now we're precisely at 100 milliliters. The curved portion of the solution that we've created is in the neck of that 100 milliliter volumetric flask, and the meniscus sits at the bottom right at that scale marking. So we've created precisely a 100 milliliter solution that has magnesium chloride in it. And what we want to report is the concentration of the magnesium ions and the chloride ions. If we turn to the left side of our data page here, we see the concentration, the molar concentration of each of these species, and we would recognize that the chloride ion is twice the concentration of a magnesium ion. So I want you to report your data, and I want you to show by how magnesium chloride breaks up as to why this is true. Why do we get twice the concentration of chloride in comparison to magnesium ion? You'll also, for this activity, repeat this exercise using a 250 milliliter volumetric flask. And what you're going to predict in this case is what would be the concentration of the chloride ion and the magnesium ion if we add 1 gram of the magnesium chloride to the 250. So you'll repeat this exercise to become proficient at using the glassware in our virtual lab. So that's it for today. Good luck.